Lesson 5 is on using our identity and our inverse properties to write equivalent expressions. So again, remember the whole theme that we've been working on basically is being able to kind of manipulate different expressions, put them in different forms to help us later on. So this is now moving to the next step as we get ready to start really solving equations. So identity. If we're talking about identity, it keeps its identity. An example of that would be 5 plus 0. If I add 0 to 5, 5 keeps its identity. Another example would be 5 times 1. If I multiply 5 by 1, it keeps its identity. It stays 5. Okay, so adding a 0, multiplying by 1, those are identities. Inverses, we've been talking about additive inverse and multiplicative inverse. And basically, if I do an example of those, if I take 5 and I add it to its opposite, a negative 5, I get 0, okay? If I think of multiplying here, and I multiply 5 by its reciprocal, 1 over 5, that adds up to be 1, okay? So opposites, reciprocals, those are all considered inverses, okay? So we're going to use these properties to, again, write equivalent expressions, right? Equal expressions. In the morning, Harrison checked the temperature outside to find that it was, negative 12 degrees. Later in the afternoon, it rose 12 degrees. So it was negative 12, and then it rose 12. Write an expression representing the temperature change. Well, if the temperature was negative 12 degrees, and then it rose, it went up 12 degrees, I'm going to add those together, and guess what? If I have negative 12, if I have negative 12 degrees on a number line, and I add 12 to it, I am at 0 degrees Fahrenheit. Okay? Notice that these are opposites. Okay? And opposites add to 0. Keeping that in mind, and again, guys, if I'm going too fast here, we got a lot to cover. Feel free to pause it and write stuff down. We're going to deal a lot with opposites. Part B here says rewrite the subtraction as adding the inverse for the following problems and find the sum. Okay, inverse, opposite. Okay, by adding the opposite, keep, change, change. That's basically what we're doing here. If I could spell correctly, or neatly, I guess I could be a little better about that. So we're rewriting subtraction as addition. The way subtraction becomes addition is subtracting is the same thing as adding the opposite. So instead of saying 2 minus 2, we can say 2, subtraction is the same thing as adding the opposite of 2, which is a negative 2. Keep, change, change. Then we have to find the sum. Well, notice that these are opposites. If you think of a number line, if I go to the right 2, excuse me, and then I go to the left 2, I'm back at 0. Right here, subtracting is the same thing as adding the opposite. Keep the negative 4, change the minus to a plus, change negative 4 to its opposite, a positive 4. Opposites, opposites add to 0. Difference, when we see the word difference, that means subtraction, okay? And wherever you see the word and, that's where we're going to be putting the subtraction sign or the addition sign, okay? And we'll get to that in a little bit. So we're taking the difference of 5 and 5. Keep, change, change. 5 plus a negative 5 is 0. Well, that makes sense, right? 5 minus 5 is 0, okay? The reason, we just got to get comfortable knowing that because sometimes it can be subtraction, sometimes it can be addition. Well, what if we have these symbols here representing numbers? Does that change everything? No. Okay, g minus g, it's going to equal 0, right? Just think of it. If you have g of something and you take away all of it, you're left with 0. If we change this to addition, like directions say, keep the g, change the minus to a plus, change the other symbol g to its opposite, a negative g. They're opposites. Opposites add to 0. Inverses. Additive inverses add to 0. Okay, so what pattern do we notice in all of this? Well, what did we do? Well, in all of these, we changed them all to addition. Okay, so what pattern did I notice? Okay, all adding. because I made them that way, right? What else did I notice? We used opposites, right? This is what we call additive inverses. Additive inverses, and what are additive inverses known as? Opposites. Actually, what are opposites known as? Additive inverse. And what did they all equal? Our additive inverses are opposites. When you add them together, they always equal 0. Okay? That's going to be important as we get into solving equations. Like duh, right? We know that if you add opposites, it gets a 0. But that's important when we solve equations. Okay? Okay, so that's our additive inverse. Now let's work maybe on our identity property here. We're not going to think too hard about this. Okay? This is add or subtract. What is 16 plus 0? Well, if we add 0 to anything, does it change? No. Keeps its identity. Now we have 0 minus 7 here. You might know that's negative 7. If not, we can change it to addition. Keep, change, change, right? Keep the 0, change a minus to a plus, change 7 to a negative 7. Don't just make it a plus sign. 0 minus 7 is not the same thing as 0 plus 7. It's the same thing as 0 plus a negative 7, though. And again, if I add 0 to negative 7, nothing's changing. It's staying negative 7. Negative 4 plus 0, guess what happens when I add 0 to negative 4? It stays negative 4. 0 plus d, variable. Now we just can't do this problem. What happens when I add nothing to d? It's still d, okay? And these are identity properties. It's keeping our identity. Now technically, this is the identity property of 0. Not that you really need to be concerned with the name of it. Their identity property of 0, identity property of 1. That's multiplying. So what pattern do we notice through these here? Well, what did we do every single time? Added 0. And guess what happens when we added 0 every single time? The number. And I'm going to say the number, even though this is, you're like, wait, there's a letter there, Mrs. Messing. No, that's a symbol representing a number. So the number, the number being added stayed the same. Being added to 0, I should say. Now I'm going to say is the answer. How's that? Trying to think of the best way to write it. Maybe that wasn't it, but that's okay. Okay, whatever we added to 0 stayed the same. It was our solution, was what it equaled. Okay? All right. Don't overthink this lesson. Tend to do that a few times. This right here is what you're going to see in your homework, okay? So up until this point, we're really just focusing on inverses and opposites and adding it's at 0. This right here is what you're going to see in your homework, so pay close attention to this part. Write the sum. What does sum mean? It's a solution to an addition problem. And then write an equivalent expression. We've been doing that by collecting like terms. We've been doing that and removing parentheses. We've been doing that, okay? So where you see that and right there, that's where your plus sign is going, okay? So if we want the sum of 2x and negative 2x plus 3, and is where you put the plus sign. If it's a difference, that's where you put the minus sign. If it's a product, as we're going to get to, that's where we put the multiplication sign, okay? So we're just going to go 2x and, so plus, negative 2x plus 3. Now this is what we were working on the other lessons, okay? So don't overthink this stuff. Combine your like terms, right? Like terms have identical variable parts. Do not go 2 plus negative 2 plus 3. No. Like terms, remember, are the x's. If I have 2 x's and I add negative 2 x's to that, then I have 0 x's. What is 0 times anything? 0, right? So it's not going to do anything. So 2 x's plus negative 2 x's is 0 x's. And then we have our plus 3. Well, 0 plus 3 is just going to be equal to 3. Okay, so it might look a little more confusing, but we're really focusing on these opposites. All right. We're finding the sum still, right? 2x minus 7 and plus sign. The opposite of 2x. Well, okay. Well, what's the opposite of 2x? Negative 2x. right? Don't overthink it. If it's positive, it's negative. Negative is positive. So we have 2x minus 7 plus negative 2x. Change it to addition. That's what we've been doing. Keep, change, change. The more you write down, guys, honestly, the easier it gets. Try to do too much in your head. That's where you mess up. Find like our like terms here, right? If I have 2x's and a negative 2x's, I'm not going to go 2 plus negative 7. These are x terms, these are not. So if I add 2x and negative 2x, well, that's 0x again. Doesn't mean anything. Takes care of this and this. What am I left with? Negative 7. So my solution is just negative 7. Okay. All right, let's try one more. The opposite of 5x minus 1 and plus sign 5x. So the opposite, I'm going to go the opposite of 5x minus 1 and 5x. All right, this right here, you know how to do, okay? I'm going to change this to addition. I'm going to write this as plus a negative 1x, and then I'm going to distribute that negative out, or you can think of it as just multiplying by a negative 1. Negative, or negative 1 times 5x is a negative 5x, plus negative 1 times negative 1 is a positive 1. And then this 5x out here, don't give the negative to it. It's outside the parentheses. Like terms, negative 5x and a positive 5x. Guess what that adds to? 0. Gone. They're opposites. I'm just left with 1. Okay? All right. So we're going to start the next video with some more examples, but I think we'll stop right here. Again, we're taking what we did in the last few lessons, okay? And now we're going to start combining it with some opposites. And in the next video, some inverses, right? Some multiplicative inverses, reciprocals, and see how that really is getting things to cancel out.